Hello students, in this video we are going to learn is about magnetic property of d block elements. Okay, do remember magnetic property of a magnetic substance is measured in terms of magnetic moment. So whenever we measure the magnetic property of a magnetic substance, we measure in terms of magnetic moment. I've said a little bit about this in the chapter called solid state also. So we measure in terms of magnetic moment whose symbol is mu. This symbol is referred as mu. And the SI unit of magnetic moment is Bm, whose full form is B means Bohr, M means magneton. And the formula to calculate magnetic moment of a magnetic substance is mu is equals to under root n plus 2, where this n stands for number of unpaired electron. Okay, this n stands for number of unpaired electron. And you know that they are up means they are directly proportional. So more the number of unpaired electrons in an element, more will be the magnetic moment and more will be the magnetic property. Less the number of unpaired electron, that is n, less the magnetic moment, less the magnetic property. And this is how we calculate this. N stands for number of unpaired electron. So more the number of unpaired electron, that is n, more will be the value of magnetic moment and more will be the magnetic property. And vice versa means if the number of unpaired electron is less, magnetic moment value will be also less. Next thing, we need to remember the meaning of paramagnetic and diamagnetic, which is again explained in the solid state chapter. Paramagnetic means unpaired electron, and those who have unpaired electron, do remember they always suffer attraction in magnetic field. Whereas diamagnetic means paired electron, and those who have paired electron, they always suffer repulsion in magnetic field. So para means unpaired electron, they suffer attraction in magnetic field. Dia means paired electron, they suffer repulsion in magnetic field. Do remember these two. So do remember from here who measures magnetic property, magnetic moment, SI unit, Bm. Formula is here, N stands for number of unpaired electron. More unpaired, more magnetic moment, more attraction. Less unpaired, less magnetic moment, less attraction. And para means unpaired electron, suffer attraction in magnetic field. Dia means paired electron, and those have paired electron, they suffer repulsion in magnetic field. Now students, we will calculate the magnetic property of 3D series. So I am doing the magnetic property for 3D series. The same thing will go for 4D and even 5D series, but we just concentrate on 3D series. And I have already said you to remember the name of the element of 3D series in sequence in my first video: scandium, titanium, vanadium, chromium, manganese. Then comes here, after manganese comes iron, cobalt, nickel, copper and zinc. And you have to remember the atomic numbers also, that is 21 to 30. Now let us see how to make the configuration of manganese. We always write argon 4s3d. Argon is 18, 4s2 makes it 20, d1 makes it 21. 18, 19, 20, 21 for scandium. But whenever we have to show the magnetic property, we have to make ground state configuration. So for s orbital we make 1 box, for d orbital we make 5 box. Now you can see in S there are 2 electrons, so you put 1 clock, 1 anti, and in D there is 1 electron, you make it like this one. So this is the ground state configuration of scandium, no need to write argon. Now for titanium is 22, so here is 18 already for argon, 4s is 20, D is 1, in this case D will become 2. When you go for vanadium, D will become 3. Okay, when you go for chromium, D will actually become 4, but it has an exceptional configuration, I have already said you. So 1 electron of 4s, actually D will have only 4 here, and here will be 2. So 20 plus 4, 24, but it has exceptional configuration, so 1 electron has to be given to the D, whereby 4s becomes half filled, 3d orbital also becomes half filled and stable. So this is the configuration for chromium. Now for manganese, 25, so we write here 2, 20, 21, 22, 23, 24, 25 for 4D, 4s2, 3d5 for manganese. Now when you make it for iron, okay, now when you make it for iron students, what you have to do, 4s, argon is 4s, 2, then 3d becomes 6. So 1, 2, 3, 4, 5, 6. I'm applying Hund's rule here. And it will become 7. So again 1, 2, 3, 4, 5, 6, 7. When you go for nickel, it will become 8. When you go for nickel, it becomes 8. 1, 2 is already here. So here will be 1, 2, 3, 4, 5, 6, 7, 8. Now when you make it for copper, here should be 9. 7, 8, it should be 9. But you know that copper also has exceptional configuration, so one electron of 4s has to be given here to make the orbital fulfill. So it will have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 4s is half filled, 3d is fulfilled, so it's stable. Exceptional configuration for copper. Now finally, when you go for zinc, it will have 30. So argon 4s2. This is 4s2. Now 3d will be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is how we make the configuration from scandium till your zinc. Now you can see out here, here is 1 ampere in scandium. When you go to titanium, it's 2, chromium, vanadium 3, chromium 5, manganese 5. So from scandium till manganese, if you see this arrow, number of unpaired electron is increasing. 1, 2, 3, 5, 5. Number of unpaired electron is increasing. So number of unpaired electron increases from scandium to manganese. And as the number of unpaired electron increases, magnetic moment value will also increase. And more the unpaired, more the paramagnetic nature we say. So if unpaired electron increases, magnetic moment increases, paramagnetic nature also increases. And they will suffer more attraction in MF means magnetic field. So attraction in magnetic field will also increase. But from the midway, if you see from the midway what is happening, pairing of electron is occurring in the d orbital. Till here there was no pairing. Now here is pairing is occurring in the d orbital, whereby the number of unpaired electron will decrease. Here is 5, now it became 4, it became 3, it became 2, it became 1 unpaired, and here 0. So that means from after the midway from manganese onwards, iron, cobalt, nickel, copper, and zinc, number of unpaired electron will decrease. 5, 3, 2, 1, 0. Number of unpaired electron is decreasing. So magnetic nature will also decrease, means magnetic moment will also decrease. So as the number of unpaired electron decreases, paramagnetic nature will also decrease, whereby attraction in magnetic field will also decrease. So do remember in 3D series, students, in the beginning of 3D series, paramagnetic nature increases due to increase in the number of unpaired electron. But after the midway, paramagnetic nature decreases because pairing of electron will start occurring in d orbital, whereby unpaired electron will be less, so paramagnetic nature decreases. And at the end, there will be no unpaired electron. So at the end, paramagnetic nature becomes 0. Okay, so it can be explained with the help of one question. So it is out here, students. You can see this question. In transition series, paramagnetic nature first increases till the midway, till manganese. After the midway means after the manganese, it decreases. And at the end, it becomes 0. Explain. This is the question of ISC. So I repeat again the answer from here, students. In the beginning of transition series, as the number of atomic number increases, number of unpaired electron also increases, thereby paramagnetic nature also increases. But after the midway, that is from manganese onwards, pairing of electron will start occurring in the d orbital, whereby the number of unpaired electron will decrease, whereby paramagnetic nature will also decrease. And at the end, if you see there is no unpaired electron, so paramagnetic nature becomes 0. And the answer is here, students, for this. In the beginning of transition series, number of unpaired electron increases, as I have explained just now, due to which paramagnetic nature will also increase. But after the midway means from manganese onwards, pairing of electron will start occurring in the d orbital, due to which number of unpaired electron will decrease, and hence paramagnetic nature will also decrease. At the end of any transition series, d orbital will be completely filled with electron. In case of zinc, I have shown you just now, due to which there will be no unpaired electron for zinc. You can see there is no unpaired electron for zinc, so paramagnetic nature becomes 0. So this is also a very important question, students. If you want, you can take the screenshot of this. Okay. And so, students, one thing you need to remember is this one. If the number of unpaired electron is more, boiling point and melting point will be also more. But if the number of unpaired electron is less, then melting point and boiling point will be also less. So zinc, cadmium, mercury are the bottom elements of all the 3 series. 3D series, the last element is zinc. 4D series, the last element is cadmium. And 5D series, the last element is mercury. And in all this last element, d orbital is completely filled. I have shown you in case of zinc. Similarly, the same thing happens in case of 4D series with cadmium, in 5D series with mercury. So their d orbital is completely filled with electron, means they don't have any unpaired electron. As a result, they have low melting point and boiling point. In the given elements, d orbital is completely filled with electrons. I have shown you in case of zinc, the same thing will happen in cadmium and mercury case also. So since their d orbital is completely filled, due to which there is no unpaired electron with them, hence the bottom element of all these three series will have no melting point and boiling point. That is for cadmium, calcium, zinc, cadmium and mercury. The next important question out here is this one, students. In 3D series, which shows maximum paramagnetic nature in +2 oxidation state? Answer is manganese. But how? Let us see. In 3D series, who shows maximum paramagnetic nature? Means those who have maximum unpaired electron, they will show maximum paramagnetic nature. In which state? +2. And the answer is manganese. Now let us see how answer became manganese. So check here, students. Now this is normal scandium. To make it +2, you have to remove +2 oxidation state, the question was saying. So to make it +2, you have to remove 2 electrons from 4s. So if you remove 2 electrons from 4s, how many unpaired electrons it has? 1. To make it +2 oxidation state, remove 2 electrons from 4s. So how many unpaired electrons? 2. To make it in your +2 oxidation state, you have to remove electron from 4s. So how many unpaired it has? 3. To make it +2 oxidation state chromium, you have to remove 2 electrons. So one you remove this, one you remove this. So unpaired electron will be 4. And in case of manganese, to make it +2 oxidation state, remove 2 electrons from 4s. So the unpaired electron will be 5. So here unpaired electron will be 1, here will be 2, here will be 3, and here will be 4. Because you remove these 2 to make it +2. So it will be 4 and here will be 5. So from scandium to manganese, the number of unpaired electron is 1, 2, 3, 4 and 5. So students, in +2 oxidation state, scandium will have 1 unpaired electron, titanium will have 2, vanadium will have 3, chromium will have 4 and manganese will have 5. Till here you understood? Now let us see for the rest. Now similarly, to make iron +2 oxidation state, remove 2 electrons from here. So the unpaired electron left is 4. To make it +2, remove 2 electrons from here. The unpaired electron left is 3. Here is 4, here is 3. To make it +2, remove 2 electrons from 4s. The unpaired electron is 2. So here is 4, here is 3 unpaired, here is 2. Now to make this unpaired +2 oxidation state, you have to remove 2 electrons. So one you remove from here, one you remove from here. So unpaired electron will be 1. So here will be 4, 3, 2, 1 unpaired. In case of zinc, you will remove 2 electrons to make it +2 oxidation state, that you remove from 4s. So here is no unpaired electron, so unpaired electron will be 0. The number of unpaired electron in iron will be 4, here will be 3, here will be 2, here will be 1 and here will be 0. You can repeat the video to understand. Okay, so students, here the number of unpaired electron with iron will be 4, with cobalt will be 3, with nickel will be 2, with iron, copper will be 1 and with zinc will be 0. And if you follow the trend of a number of unpaired electron in the 3D series, it's like this: 1 2 3 4 5 5 3 4 3 2 1 0. Same thing will happen in case of 4D series, same thing will happen in case of 5D series also. First unpaired electron increases, then decreases, at the end become 0. So if you see, more the unpaired electron, more the paramagnetic nature. So that means the paramagnetic nature will increase till manganese. Then more the unpaired, more the paramagnetic nature. So who will have the more paramagnetic nature? Manganese. After manganese, unpaired electron is decreasing, so paramagnetic nature will also decrease. So if you compare here, who has the highest unpaired electron? Manganese in +2 oxidation state. Therefore, more the unpaired, more the paramagnetic nature. That's why manganese shows maximum paramagnetic nature in +2 oxidation state. So answer is manganese. Hope so you all understood. If you want, you can take the screenshot of this to make the notes. So hope so you all understood till here. So in my next video, I'm going to discuss more about D block elements. Thank you very much.